Hello, we are here for one more lesson of this AxisVM training course. In the topic for today, the toolbar loads, and in fact, we will split these informations about loads toolbar into different video lessons, being the first one today. So we are in this toolbar already. The appearance it's this one, and a brief description about what we can do in this toolbar. So we can apply various static loads for static, dynamic, and buckling analysis, and we can define also concentrated masses for vibration analysis. Let us try to create a couple of situations and describe some cases. So the first option, called load cases and load groups, we open this kind of dialog box. I have undiscriminated some cases here, doesn't matter. So this command lets the user to set the current or create new and modify existing ones load cases. So we can create different kinds of things. So we can create very specific load cases, like this one. If I say create a static, this line is added to the list, and I can define a name. Okay, simply this. And we can apply this concept to several other types of loads. So describing briefly what we have. So we have the first one, which we've seen already, called the static. So we can apply a static load case to some different cases, static, vibrations, buckling, and we have a couple of options or parameters to deal with this. We have the second one that is called influence line, and this lets you apply a relative displacement load to obtain the influence line of a result component, and we can do this on a truss or beam element. Then we have a moving load. I can finish this. Okay, we have a moving load, and in this moving load we have several parameters which we can define. Okay, we can define a couple of options here, and we have also regarding the regulation that we choose, we have several possibilities to choose from. Okay, so we have this kind of possibilities inside the code that is chosen. And this moving load can define a load that is moving with different characteristics. Okay, there are a couple of additional descriptions for these and other items in our theoretical course, which I strongly recommend you to check. Now seismic loads. Okay, in this particular case, I cannot add it because I don't have a vibration result. Okay, but basically here we can specify parameters for calculation of earthquake loads. And this has, for the moment, a specific module. So we have, we require a SE01 module. The same for pushover analysis. We can define a couple of options also for pushover. Again, this one requires pre-calculated vibration analysis. And these require also a SE2 module for the moment. And I'm saying for the moment because when a new version is released, some of the modules that were add-ons are incorporated inside the main package. Now we have this one called the global imperfection. And this can be defined also for some load combinations. We have this one, which is called dynamic load, which has also some possibilities. Another one called tensioning, and tensioning has also some possibilities. This is required also for some definition of tensions inside the model. We have the fire resistance module also, and I forgot, okay, fire, and we can have also fire defined. And finally, we have also two other modules, which are the snow and the wind. To mention that this fire load requires a specific module called the SD8 also. It has a couple of parameters. And these ones, both wind, we have also specific regulations and parameters, and snow, which has also this kind of stuff. So there are a lot of different informations to check on, and again, our theoretical course has all those additional explanations. For these wind and snow loads, we require also a specific module called SWG, which is necessary to perform this kind of calculation. Then what it happens, it is that we can add also some, sorry, just to check my sheets, okay. We can add, in all of these guys, we can add groups and we can add conditions, because you know that we have two different lines of products inside AxisVM, called one small business and the other professional. In small business, we have limitation of the number of load cases we have. In professional, it has no limit. So this is a important characteristic for who has one or the other. Then we can add also a couple of other conditions here, okay? Still regarding these load cases, and then we can add these groups, which are this one is permanent, this one is variable, this one is accidental, and this one here, moving load group, tensioning, seismic loads, and fire loads. So we can add these groups for the necessary calculations also. We will see in more detail a couple of things related to this topic. So for the moment, I would like to leave you with this concept, because I think for the moment it's enough. You can check also our videos that we are releasing with examples, because we have a couple of examples about all these topics. Then we have another command called load combinations, and this lets the user define load combinations of the defined load cases. So we have this table browser here, where we have, among other entries, also load combinations, and we can define load combinations. We can define the type, and we can define the parameters for each one, okay? And after all of this done, we can perform the calculation. Which is not very difficult to deal, but it's a main part of the calculation itself. Then we move on for the types of loads. The first one, it is something called a nodal load, and lets the user apply forces or moments to selected nodes. So these are very similar two things we've seen previously. So we can define the nodes. I've chosen all, and we say, okay, we can define the amount of the loads we are defining on those nodes in this particular case. Then we have another one called concentrated load on beam. The procedure is always basically the same. I would try to choose all always to be as example. And in this particular case, again, we can define values. Okay, let me say something here. And this is applied to whatever we have chosen. Then we have another one called point load on domain or load panel. Again, we can define a force or a momentum, and we can define it in this particular case. It's a point concentrated on a location that is given by the cursor or that I've picked directly in my screen. So this is, I think, a very easy example to explain what we can do with this one. Then we have another one called distributed line load on beam or rib. So again, we can choose one element. We can define the values. So for example, and we can say for which type of load, which can be a segment, can be a trapezoid or a triangle, and this will change according to what we give. So basically it will apply that on the element that was chosen. Another one following this order, it is domain load panel line load, and this applies a uniform or a linear distributed line load over a domain or a load panel. So we can define something. Sorry. We can define something. Then we can define a shape. I will leave a line to be easy. And we can define something like this, okay? Next one, it is a surface load. Surface loads can be applied on surfaces, domains, and load panels. So surface loads, we can choose, let's say, all, okay, and then we define the values to apply this. Next one, we can apply a load to a domain or a load panel, which is different from the previous one. So we can define, and we can also define the shape of the things, a constant load or a linear load. We can define the shape of what we are applying, and we have another condition in here, which is to say if the loads disappeared or are allowed on holes or not, which is also an important parameter to supply to the system. So let us say something, and I can apply this kind of stuff on my geometry. Going to next one, just 1 second to reach my my papers. We have this one now called surface load distributed over line elements. Okay, auto. This is very similar to the previous one, but the idea here is to apply a load, homogeneous surface load over a line element, and this line element can be a truss, a beam, and a rib. So basically we can say this. I can define a value. I forgot always to apply a value. Let us say this. Okay, in this particular case failed, but I'm doing this a little random, so just to give you the idea. Another one called load panel, and we can use these guys to define snow and wind loads in these load panels, and we must define these load panels before. Okay, so the idea here it is to define a load panel. We have a couple of parameters to work with. I will do this a little random, okay? And I think they are all done, I suppose. And now I can go to these load cases. I'm not sure if I said, I think it was wind. Okay, sorry. Let's go there again. I can say domestic, whatever it is, and I should have, okay, I should have already the possibility to define a wind load where I can create, I can give a name, let us say all, and I can define all the parameters. Okay, there are a lot of things in here, wind velocity, season factor. We can define the type of roof that is applied with all the necessary parameters to apply this. Okay, a lot of things. And the snow, it is also very similar to this one, but we will see in a bigger detail how to apply this in the next lesson in very specific cases. Moving a little up front with this, and I'm mentioning that both of these guys, snow and wind, with the specific parameters that each one has, it is applied and it is worked on a very similar mode. Let's move on to let's try to get out of this. Okay, let's move on to this one called fluid load. In the fluid load, I can define all the elements. Let's the user apply a load pressure characteristics to fluids, and these are applied to the elements. So we can define this kind of stuff, okay, with all the parameters, and this can simulate, for example, water, which in this particular case it was already defined. Then we have also another one called Selfweight, and with this we can consider the self-weight of the elements with the materials that are assigned to the elements, and this adds one more item to the calculation that we should do. This one is called fault in length, or we can say it in other words, it's a fabrication error. And this load type is used when a structural beam is shorter or longer than the required due to a fault in manufacturing. So I think I have only this element here, and now I can say what is the dimension so that this is considered on the calculation. Another one called tension and compression, and in here we can define an initial actual internal force in a truss or beam element. So again, let us choose the same one and we can define this internal force. Almost ending, we have three more. The first one, it's thermal load on line elements. So if I choose only these guys on top, We have some parameters for these line elements regarding temperatures. So we can apply temperature loads on the selected elements, and then it's simply mentioning which parameters we are considering. Very similar, it is this one called a thermal load on surface elements. I would say all of them also. And we have a very similar dialog box. And finally, we have something called forced support displacement. This one, I have only one nodal support, but it is chosen. Now I should give the necessary parameters, but this option here lets you apply forced displacements on the selected elements. This one, okay. And then we must specify the values of the components. So if it is a translation, we should give them around here. If it is a rotation, we should give them around here. So basically, it's what we can do with this command also. To finish, just to mention that we have very important additional information on the theoretical course, so I strongly recommend you to check all of those items. Anyway, if you need any additional help about this topic, we can try to give you all the necessary support. And finally, to mention that this topic will have more information on the following video.